Hey, this is Joe, graybenchelec. Welcome back to the pedal teardown series where I take apart new and interesting pedals and show you what's going on inside. Today we have the Crowther Hot Cake. Okay, Crowther Hot Cake, designed by Paul Crowther, 1976-77, one of the original boutique guitar pedals. You could say perhaps flies under the radar a little bit just because Crowther doesn't really do any marketing for these pedals. As far as I know, you still have to order them direct from Paul, but they have gone through several revisions over the years. This, I believe, is the second to last version. The most recent version has external switches for some of the available mods inside the pedal. This version has the internal switches. So we're not going to spend too much time looking at the insides of this pedal, and you'll see why in a second. We will have a look, though, at the schematic for the pedal, and especially some pictures from Ion Effects when they did a trace of this pedal. And we will talk about the circuit and how it has some interesting features that are worth looking at. So for externals, we have simple 1590B size enclosure, Hotcake graphics. Three controls here are level, drive, and presence. Latching foot switch, side mounted, 1/4-inch jacks, Kobicon style internal nut DC jack, white powder coat. Back window here has the information made by Crowther Audio, Auckland, New Zealand. It's got the serial number, tells you the polarity of the DC jack. Input specifies battery on, so when you unplug the input, it disconnects the battery. Let's go ahead and crack open the pedal. All right, so here's the insides of the Crowther Hot Cake. First off, inside door has the same information that's on the back. Crowther Audio, Auckland, New Zealand, made using lead-free solder, apparently. So this is what hotcakes look like inside. They have a piece of cardboard here covering up the circuit board, and underneath there is some gray kind of silicone putty or caulk holding that gray cover on, and also obviously gooping the circuit. The markings here, we have N-BB, that's referring to this switch here. So this is choosing between normal mode and the Bluesberry mod. Over here we have, I'm not sure what this symbol is supposed to be, and then B for bass. So push to the right is the bass, and over here is non-extended low frequency, XLF. Serial number, copyright symbol, Paul Crowther's little signature or initials, and then not sure what that says there. Switches, or I should say the input jacks or input and output jacks are Switchcraft. Stereo jack, of course, for the battery snap to disconnect the battery while the input jack is removed. Kobicon DC jack. The foot switch here is a double pull, double throw foot switch. That's going to be important later when we look at the schematic. Battery snap's kind of a funky plastic looking one here, and otherwise pretty straightforward. It is a Hammond 1590B chassis or enclosure. Like I said, not much to see inside because it's gooped and covered up. But let's go over to the computer and look at the tracing journal from Ion Effects, and then we'll be able to see the circuit after it's been degooped, and we'll look at the schematic as well, see what the Bluesberry mod is, see what the XLF mod is, and talk about some other interesting things with that circuit. All right, so first off, shout out to Ion Effects for tracing and degooping the hotcake here. They have a bunch of great information here. I'm not going to read through all of this. I just want to shout out Ion and say that if you want to build your own Crowther hotcake, check out their Anomaly Vintage Distortion board here, and you can use this to build your own clone of the hotcake. Ion goes through all their tracing process here, talk about different variants, including the Bluesberry, the XLF. That's what is shown, or that's what is controlled with those little switches on the hotcake I have here. Scrolling down here, so this version that was traced is actually the same, I guess, iteration as mine, which is to say has the internal switches, like so. Let's go back there. Here is what the board looks like underneath that cardboard and degooped. So we've got resistors and capacitors, obviously. We have this transistor here, which is interesting. We'll look at that in a second. We also have a big resistor going over top of the IC here, and a silicon diode here, and a diode here. Keep those in mind. Here's a little bit more degoopage. Interesting to see the way the cables are sort of wrapped around each other here, sort of like string relief unto themselves. And here's the back of the board. Scrolling down, here is the schematic for the hotcake. Actually, let's just go back for a second. Just want to see, talks about different stuff that they've discovered while they were tracing the pedal and degooping. It also talks about the interesting transistor, so I guess we can look at that. There are other versions of the schematic available. Let me just see. So here is the 2003 schematic, or I should say this is the 2007 schematic of a Hotcake from 2003. And that's this trace here. And here is a Hotcake from 1977. These are both drawn by Analog Guru, or this person here, Godfrey DeVos, popular in the DIY crowd. So yeah, so here's Ion's schematic for the Hotcake. So we come in here, pull down resistor, 10 nanofarad input cap, bias resistor for the power supply, giving bias to our op amp here. It's a TLO71, so it's a single JFET input op amp. There's also been 741s used. Pretty standard setup here. The feedback loop is just sort of drawn sideways, but we have our sort of filter tail coming off here to give the ground reference for the feedback loop. And we've got the 10K. There's some filtering happening here with these capacitors and resistor networks. And then the presence control is a potentiometer here in the feedback loop. The XLF here, the extended frequency response, is just bringing another capacitor in parallel with the output of the op amp. When you put capacitors in parallel, you add together the capacitance, and so you're going to get more low end. When you pair that with a level controller ground, you're creating a high pass filter, and you're dropping the roll-off frequency when you add in capacitance like that. And then we have level control and then out through that 1K resistor. But really the interesting thing here is this transistor here hooked up to the pin 5, the TLO71. This is the Null Offset Pin. Just like Ion Effects admits here in their information, this is over my head as well. But I think the summary that Ion gives here is a good one. So in Bluesberry mode, the offset null pin, that is pin 5 here, the TLO71. The offset null pin is used to cause the op amp to clip without hitting the power rails, which is the source of the harshness in non-Bluesberry mode. And just in general, when op amps clip, they sound harsh, especially if you're used to the soft clipping with diodes in a feedback loop, or even hard clipping with diodes to ground. The sound of a clipping op amp is usually very harsh. When Bluesberry mode is disabled, Q1 is out of circuit and offset null pin is not used. In my experience playing them back and forth, I couldn't even really tell a difference between the two. It might be something you only experience really at a cranked up gain knob, because that's when you're going to start to hear the op amp itself clip when the Bluesberry mode is off. Personally, and I think I speak for a lot of guitar players, the Hotcake sounds better when the gain is rolled down, used more as like a dirty boost sort of thing. Another thing I want to point out, and it's not shown here in the Ion Effects schematic because this is for, their board, but it is shown in the schematics from Analog Guru. The switching is interesting here. As we saw in the pedal, it's a double pole, double throw switch, and there is an LED. So that has to be done a special way. With triple pole double throws, you have an extra pole that you can just hook your LED up to and switch it on and off. But for a double pole double throw, you gotta do something different. So in this case, it's actually pretty clever what's being done here. We have a transistor that is going to turn on this LED. So over here, we have our switch here, S1. This is the foot switch. The schematic here shows the pedal in the on position. So our foot switch here is switching between connecting this piece to these components here, resistor, capacitor, and then the coil for the relay. So that's either being connected, the coil here is being connected to the power supply, or when this switch is thrown the other way, it connects all this to ground. So the coil is de-energized, causing the relay to switch back. So when the relay switches here to the on position, we can see here that this is connecting this top, or I guess I should say the bottom rail here, all this is connecting to ground, which is going to connect that tail for the feedback loop to ground, essentially turn on the pedal. When these two switches here flip back, we'll see here that this bottom rail here, instead of connecting to ground, it's now going to connect over here to the top of the drive pot. So the drive pot ends up getting bypassed and the ground reference is lost for that tail. All of that is essentially going to deactivate all of this stuff in the feedback loop, and it's going to turn this pedal into essentially a op amp buffer. So that's a pretty clever thing. So when the pedal is bypassed, you're not getting the gain that's being created by the pedal here. You're just getting op amp buffering. You're getting a low impedance output from the op amp. So the Hotcake is not a true bypass pedal, it's a buffer bypass, and it's done a pretty clever way. As far as the LED here, so the LED is being in the on position. The base here of the transistor is not connected to ground through this bottom part of the relay. and it's getting some bias current through R12 collected up to the power supply, which is going to cause your collector current to flow, and that's going to turn on the LED. When you flip the relay over to the off position, now the base is connected to ground, which means the current won't flow through the base, it'll just flow straight to ground, which means you won't have any current flow, which means the LED will be off. So those are the internals for the Crowther Hot Cake. All right, so that is the Hot Cake. Let's go ahead and put the pedal back together. All right, that's a wrap on the Crowther Audio Hot Cake. If you have any recommendations for a pedal you want to see on a future teardown episode, let me know in the comments. If you enjoyed the video, I'd appreciate you hitting the like button and subscribing, and hit the notification bell if you want to know when I make a new video. I am Joe from Graybench Electronics. Thank you for watching.